Hello, my dear students, and welcome back. Your board exams are just around the corner, right? So we're going to make sure you're totally 100% prepared. And today, we're going to tackle a chapter that can get you full marks if you just pay a little bit of attention.
I know. Determinants can look a bit scary, right? All those lines, all those numbers. But hey, what if I told you it's actually one of the easiest, most scoring topics out there? Trust me on this. In just the next 5 minutes, we're going to turn all that tension into confidence. You'll be solving problems like an absolute pro. So here's our game plan for today. First, what's a determinant? Then, we'll jump into some easy ways to calculate them, find minors and cofactors, unlock the mighty matrix inverse, and finally, solve some actual exam problems, fast. It's a clear, simple path to full marks. Let's do it. Okay, let's dive right in. First things first, what exactly is this thing called a determinant? Well, think of it this way. It's kind of like a unique ID card, but for a very specific type of matrix.
So every single square matrix has this special, unique number that's associated with it. And that's what we call its determinant. It's like his Aadhaar number, you know? This one single number, which we write as det of A or with those two vertical lines, holds so much key information about the matrix. Like it tells us if we can solve certain equations with it. It's super, super useful, as you're about to say.
Now, this is a very, very important point, Beta. Please lock this in your brain. You can only find a determinant for a square matrix. That means a matrix with the same number of rows and columns, like a 2x2 or a 3x3. No rectangles allowed here, okay? This is such a classic spot for mistakes, so don't you be the one to make it.
All right, enough with the theory. The real fun in maths is in the solving, है ना? So let's get practical and learn how to actually calculate these determinants. We'll start with the simplest one. Chalo.
For a 2x2 matrix, it's just beautiful, so simple. Look at the calculation on the screen. You just cross-multiply. First, you multiply the top left A with the bottom right D. Then you subtract the product of the other two, the bottom left C and the top right B. It's just A times D minus B times C. Just think of it like down arrow minus up arrow. Easy peasy. Okay, let's practice with a question straight from your NCERT book. This makes it super relevant for your exams, right? Have a look at this 2x2 determinant. You know what? Pause and try to solve it yourself right now. Go on, give it a shot. And the answer is 8. Did you get it? I'm sure you did. Let's see how. We do the down multiplication. 2 times 2, that's 4. Then the up multiplication, 4 times minus 1, that's minus 4. So the calculation is 4 minus, and be careful here, minus 4. And what happens when you have a minus and a minus? They become a plus. So it's 4 plus 4, which equals 8. Simple. Now for the big one, the 3x3 matrix. It looks complicated, I know, but it's just a simple pattern. It's easier than learning a new Instagram reel dance, I promise you. So you pick an element from the first row, you cover up its row and column, and you multiply it by the little 2x2 determinant that's left. You do this for all 3 elements, but just remember the pattern of signs. It's always plus, minus, plus. So that middle term, it's going to be subtracted. Finally, you just add up the 3 results. That's all there is to it. Now this is an exam-winning trick, straight from page 80 of your textbook. This is a lifesaver, bachon. If you see a row or a column with 1 or more zeros, always choose that one to expand along. Why? Well, because anything multiplied by 0 is 0, right? Which means less calculation, less time, and fewer chances for silly mistakes. It's all about working smart, not just hard. Okay, you're doing great. You've totally mastered the basic calculations. Now let's move on and see how this all builds up to the really powerful stuff. For that, we need to learn about 2 little helpers called minors and cofactors. Think of them as the building blocks for finding the matrix inverse. So what's a minor? Well, it's exactly what we were just doing. Remember when you picked an element and hid its row and column? That 2x2 determinant that was left over? That's its minor. See? You already know how to do it. We're just giving it a formal name now. And a cofactor is even simpler. It's literally just the minor with a sign attached to it. Just look at the formula. If the row number I plus the column number j is an even number, the sign is positive. If it's an odd number, the sign is negative. So a cofactor is just a signed minor. It's just a tiny little upgrade, nothing to worry about at all. All right, but chill. This is it. This is the grand finale of our theory part. The whole reason we learned about determinants, minors, and cofactors. We are about to unlock the mighty matrix inverse. This is your mathematical superpower for solving those big, complex systems of equations questions.
But wait, before we find the inverse, we have to perform one crucial check. We find its determinant. Now, if the determinant is not 0, the matrix is called non-singular, and its inverse exists. Hooray! But if the determinant is 0, it's called singular, and its inverse does not exist. Game over for that problem, you can't go any further.
Okay, one last piece of the puzzle, my dear students. The adjoint. It sounds fancy, but it's easy. After you find all the cofactors for a matrix, you arrange them into a brand new matrix. Then, you just take the transpose of that matrix, which just means you swap the rows and columns. That's it. That's the adjoint of A, or adj. And here it is, the magic formula that brings everything together. You need to tattoo this on your brain for the exam, okay? The inverse of A is equal to 1 divided by the determinant of A, all of that multiplied by the adjoint of A. This is the key that unlocks everything. Theory part is done and dusted. Now for the best part, using our new knowledge to absolutely crush those exam questions and get those full marks. Let's put our new superpower to the test and become board exam bosses. Have a look at this. A classic word problem. The kind that can take up a whole page and look super intimidating. You see this in an exam and your heart rate goes up a little bit, right? Well, not anymore. With our new skills, this is going to be a piece of cake. The very first step is to just calmly translate the words into math. As you can see on the slide, that scary-looking paragraph becomes these 3 clean, manageable equations. That's your first step. See? Not so scary anymore, is it? Okay, now we arrange these equations into the standard matrix form AX equals B. Look closely at the screen. See how the coefficients of X, Y, and Z form our matrix A? The variables themselves, X, Y, Z, form matrix X, and the constants on the other side form matrix B. And the solution is always X equals A inverse times B.
So now we just do the calculation. First, we find the determinant of A, which for this problem comes out to be 9. Since it's not 0, we know the inverse exists. Great. Next, we find all 9 cofactors to get the adjoint of A. And finally, we plug everything into our magic formula. X equals A inverse B, and multiply. And after all that, voila, we get our final answer. X is 1, Y is 2, and Z is 3. See? That huge problem was solved with the exact steps we just learned. Because simple. You turned a mountain into a molehill. Well done.
And there you have it. In just a few minutes, you've completely mastered the essentials of determinants. And listen, this isn't just for exams. Matrices are used everywhere, from creating computer graphics to solving complex economic problems. You now have a real mathematical superpower. So keep practicing, stay confident, and you're going to do wonderfully. All the very best for your exams, Bacho.